Welcome back for the final session of the day. And this session will run from 3 to 4:15 p.m. And my name is Kavita Gupta, and I'll be the chair for this session. There'll be three presentations for this session. And the topic for this session is using our sharing applications and other open source software for analysis. So with that, we can start. And also, I would like to request the speakers if you can stay within 5 minutes so we can all answer questions from the audience. So first up, we have Emmanuel Sikali, Michael Lee, and Paul Bailey from the American Institute for Research and NCES. And they will be presenting on using R and Shiny applications to analyze and visualize NAEP assessment data.
Thank you. I am Emmanuel Sikali with NCES. So in the first part, I will just present the statement of the problem, and then the rest of the team will present the individual parts that they work on. I am with NCES, the National Center for Education Statistics, and our mission is to collect every data that has to do with education in the US. So we collect data starting from 9 months old all the way to post-secondary. In the early days, we started by selecting samples at a national level. They were actually very large, and we started with some very interesting methodology where we will create a data file, and because they are very large, in the early 90s, we didn't have enough computational power or enough memory to work with the data. So what we had to do was to come up with this approach where we had an electronic code book that you will use to select only the variables of interest. Then that code book will create a SAS, SPSS, or Stata syntax file for you to run, and that will actually create a data file for you. And then that's where we do a data manipulation. But because our data come from complex samples, variance estimation was always a problem. So you needed a third software actually do the estimation and compute the error, the variance, and so on. For a while, I led the training programs at NCES, and most of the time when people came to the training, when they go back, they'll remember. Then, or after about a few weeks or a month, they'll call and say, well, what software do I use to start? After that, where do I go? So there's always that problem where the analyst had to remember the sequence of data software packages to use and when to use what. With the advance in computing power, open source software, we realized that maybe the best thing for us to do was to limit this burden on the researcher, have one tool that will allow for other computations. Also, as we are developing these, I started thinking about developing this R package that we call Edge Survey as education surveys. We also had to worry the fact that the data files are very big. For example, if one was to take the National Assessment of Education Progress or NAEP data file, let's say mathematics grade 4, we have to assess all the 50 jurisdictions, DC and Puerto Rico, and the Department of Defense education system, and the Bureau of Indian Affairs. We had to select all of these students, and then we also have some child urban districts. So after an assessment, we have about 250,000 students from whom we collected data, and then for each student, we have about 1,700 variables, which means that if you just have to load that in your computer, you get the blue screen of death. So that was one. So we had to really sit and think carefully about the best way to structure an open source package that will take into account other advances in computing and be able to give you give you a tool that will reduce the complexity. Most of the statistical operations have complexity of n squared. And then if you add in the dimension that's in the almost 1,000, that makes it really big. So we have to take that into account as we decided to develop this software package. So, so that's about the problem. That's about the problem and what we have to take into account as we went about developing it. Since only have 20 minutes, we have 20 minutes. I have to really go fast and let Michael continue. Let our chief software developer continue.
Thanks, I'll be from AIR. So now we're going to talk about the Ed Survey package. So I think that we put this maybe not exactly in the right session because I'm going to talk about an R package for a while, and then Mike will finish off with talking about a Shiny application that we wrote that sits on top of it. But and I was just starting to write something about Ed Survey, and I was realizing this slide is actually, which we wrote last week, is actually somewhat old thinking on this. But so the idea of the Ed Survey package is to take into account both the survey sampling aspects as well as the fact that the way that assessment scores are represented in the NCES data deals directly with how substantial uncertainty about the student score. So when a student takes a state test at the end of the year in grades 3 through 8 in the US, they take a test that's about 8 or 10 hours long. NCES goes to schools and asks them to participate. They don't want to take their students out of class for 2 days to do an assessment. So the assessment is short, it's about an hour long, which gives you an imprecise measure of the student's ability. And so they don't just use the MLE estimate, they use plausible values, which is similar to multiple imputation. So an issue here is that there's now 2 things that you need to know as an analyst. In addition to sort of your basic stats, you also have to know how to deal with survey sampling, and which is fine if you're somebody who does survey sampling all the time. But you also have to know how to deal with plausible values, which is fine if you're somebody who does that all the time. But you have to be able to do both here. And so there's a cognitive load that just getting started, that when we've been doing these trainings, there's oftentimes some frustration with this fact. So Ed Survey is supposed to be a one-stop shop where you can, for the data that's available online, you can download it, process it, manipulate it, and then do analyses. Simple commands take care of taking care of the sampling, the survey weights, and the plausible values of the multiple imputation. And then it's also simple to use. Of course, I wrote it, I think that. And sorry, I led the team that wrote it. The last thing I'll point to here is that minimizing the memory footprint. When you run a regression, you're not gonna, you don't need to first decide what variables you're gonna use, which is a little bit problematic because everybody has a tendency to fill their shopping cart up with everything early on. It'll just take care of reading in the data for you. So our basic workflow for using Ed Survey is, when did we start? Okay, still good. Is that you need to, you come to, you don't really understand the data you have, you need to understand the data first. And that means you need to be able to look at the code book. Everybody's first inclination, just from teaching these trainings, is can I just see all the data? And as Emmanuel said, with about 1,700 columns, the answer is no. You can't just look at all. You're not just going to browse this and figure out what it is that you want. You need the ability to search. And so we have the ability to search for variables with regular expressions. You can look at variable levels and n sizes and get weighted estimates of the number of individuals in various categories. From there, you can clean and manipulate the data. And Ed Survey does a lot of traditional analyses. It doesn't do the, whatever thing you're thinking of now to write the next paper that's going to change the way the world works. And so we allow you to clean the data in Ed Survey has several methods that allow you to both essentially not read in the data, but also clean it, subset it, define variables. But also you can just grab the data and get a classic R data.frame or data frame, sorry, and and then clean it that way. And then finally, whatever you do, you can use the analyses, which include regression, logistic regression, mixed models, and GAPS, which is something that NCES does a lot of, although I haven't seen a lot of other organizations doing GAPS. You can calculate achievement levels, which are another education-specific thing, do correlations, and calculate models. And there's additional stuff that's not mentioned here. So now I just want to show you a brief demonstration of using EdSurvey. Of course, you install the package and load it first. And you're going to need to read in the data. And the NAEP data, which Emmanuel mentioned, is available only by license. So you can't download it from the internet. You have to get a license from the education department. And so when I'm sure many people are thinking, well, you know, that's a reasonable size data set, but I'll just throw it on AWS and everything will be fine. No, you won't, because your license says you can't. So you'll be using a dedicated computer to analyze it. However, NCES did make available an extract called the NAEP primer. And so we use that data, it's on CRAN. So we use that data for a lot of our examples. Several of the other surveys are available for download. They're the international comparison ones. So when you hear the US compared to other countries, those data sets tend to be available online. And then because it's not really valuable to look at the entire data set, you know, it's too wide. This toy data set only has 302 columns, so, you know, it's very small. But the print function just shows you a bunch of metadata about the actual survey. And then that's used then to run analyses. And a very common thing to do with data, almost everything relates to the assessment scores. So a very common thing to do is not only think about results, and then because this is a toy data set, the weights are toys, so they have about average value of about 1. So these are not actual weighted estimates. But you can get results about not only the number of people who responded away, the weighted result, the percent and the standard error in that, but you can also get a mean scale score or a mean test score for people and a standard error on that, or in this case, breaking it down by the frequency of talking about studies at home and the student gender. That's a pretty basic analysis that's almost descriptive. You can also run regressions, and then this is just to show that we're not just calculating marginal means. I'm trying to drag down here, and we get the traditional regression output, but it also shows you information about variance estimator that was used, and of which there's 2 possibilities, both the replicate weights and the Taylor series, and then more metadata about the sample that was used. To get a little bit more into minimizing the memory footprint, I just want to say when you make a call like that regression, the data is actually stored on the disk at all times, except the metadata, and the data is read in from the disk. Whatever happens, the regression is run, and then the results of the regression are stored, and all the data is cleared off the disk, or all the data is cleared out of the memory. But this has to do with, Emmanuel represented it as a very thoughtful process. The way I remember it, we wrote the software using our developer machines, and then we went to run it, and using this toy data set, we went to run it on the real data set on a normal computer, and it just died. Oh, we've got to do something about memory management. And so this is what we did: is we essentially only read in the data that's necessary for this analysis, and then we analyze it that way. All right. So I've actually already mentioned all the analysis techniques. So the other thing that NCES has invested a lot in with Ed Survey is helping people learn it. So there's frequent workshops on learning Ed Survey. We have a large number of vignettes that explain different use cases, some cases data specific, in some cases use specific. There's the one vignette we include in the package tells you all the available. And then there's actually a substantial amount of documentation in the help, which is not always the case in open source software, but there's quite a bit went into all the help pages. So that's Ed Survey.
Okay, so about 5 minutes or so, let's talk about the INRD. So the INRD is an interactive NAEP results display, and is programmed in the RPAC of Shiny. So, oh, sorry, I might just be in a podium here. And what it does is it then visualize the results from the National Assessment of Educational Progress across years. And so what we did was took the 2017 through 1990 summary data tables, which basically include the means, percentiles, achievement levels, standard error, and so on, all the different results that populate the Commission's report on the website. And the result was calculating ourselves and then allowing state representatives and district representatives to interact with their data and also take it back home. And it would play also a QC role as well. So we can check the results for future surveys against the results that we have in the INRD. So another motivation that we had in creating it was that some of the available visualization tools on the NCES website are a little cumbersome. So for example, there's a NAEP Data Explorer and the IDE, the International Data Explorer, and you'd have to know the steps involved in creating a particular result. And if you were to falter anywhere in those steps, then you'd have to start back over or go back to the place where you messed up. You might not know. So it's a little challenging to go and redo that process. And also, it doesn't exactly allow for particular sophisticated data exploration. So what we did was we took those summary data table results, and you can see this example is the trend in 4th grade NAEP mathematics average scores by gender. And the tool is not currently available on our website, but I think there's an initiative to find it somehow. But it's a point and click where you can select the different subsets, different subsets of the population, student population, and it will autofill those selections as you go along, and then generate the plot. So you're going to see this is a line comparison of male and female, and then this also has a plot, a table that shows those same results. So a little bit of the weeds here is that this is a rectangular data set on the back end, and as these selections are made by the user, it will then limit that subset until it gets to the final results. When you take that, plot it in ggplot, and then create this interactive tool. So this example is a Virginia 4th grade mathematics by achievement level. So I can pause here as it walks through, makes those selections. Oh, sure, yeah. So Virginia, and then a particular variable, so this S race, that one would have all the different variables in the data set, and then it's selecting black to display. This shows the achievement levels across years of that particular state subset. then you can look at the table too. Yeah. Okay. And finally, we have percent of fourth grade students at or above proficient in reading. And this is an interactive state map using Plotly, a different R package. So this builds off of ggplot2 to allow some basic interactivity. Once you select a particular subset, you can hover over different states, and I'll show the percent at that level. And then you can check out the table. One feature we also have on here is you can export them to, so either SVG or PNG, what have you. Yeah, that's what we have for the INRD. Thanks, everybody.
Are there any questions? No questions? Okay, so we will move on to our next speaker. Next up, we have Rachel Bruce from the USDA and UDA support of their
If I can figure out how to exit the presentation here. F11, thank you. Yeah, well, I'm sure it's related to the weather, but okay, thank you all. Yeah, all right, thank you all, and thank you for supporting this workshop on behalf of the conference organizers. I'm Nathan Cruz, and it's a privilege to give this presentation on behalf of Noemi Gwendon, who's really our point of contact on this project at NAS. She couldn't be here today, and our University of Florida collaborators. Of course, we have the required disclaimer. In this presentation, I kind of want to motivate the need for the decision support system that we're building. Certainly for many of the things that we estimate at NAS related to crops, weather is relevant and important determinant of what happens over the growing season. You should consider the difficulty of conducting surveys to produce official publications. They have fixed data collection windows, fixed publication dates, and sometimes within a matter of hours or days, destructive events can happen. We'll see a couple instances of that. This system is also part of efforts to consolidate multiple data sources. And so that's consistent with government-wide efforts to augment our survey processes with additional sources of information. I'll talk a little bit about the project origins and the open source nature of the data, and then talk about the value added that it can provide for us at NAS. And right now it's being offered to our field offices for their routine duties, and I'll speculate on some of the other things it can give to us for purposes of modeling. The first fun fact about Mother Nature is that she does not get your memos. In this example, you're looking at one of our principal economic indicators, the monthly crop production report. By law, it is to be released no later than the 12th day of every month. And you can usually see in these official publications a gray box means something has happened and we know it. In this case, there were 2 hurricanes around and after the data collection window, which has the first of the month reference date. You can see in particular Hurricane Irma here that affected much of the Southeast, landed on September 10th. Our publication date is September 12th. So the question is, what do you want to do about that? In this image, you're seeing part of a survey instrument associated with our June area survey. And so the idea in this matrix, you would have multiple columns representing multiple tracts of land. This survey is conducted with the 1st of June reference date. It's conducted by face-to-face interviews, which makes for a lengthy data collection process. Some of our enumerators put 300 miles or more a day on their cars to visit sites. So it's approximately a 2-week data collection window. And I've added emphasis here about the to be planted or to be cut, to be irrigated. So there's an aspect of this survey in which we are asking the farmers to make a prediction or project what their activities might be. And depending on how the weather shakes out before and after that, more of the activity may be in the 2B part than anticipated. And certainly there are things that can impact those intentions. And so what I'll show you on the next slide revolves around our most recent acreage report published in June 28th. So what you're seeing is based on the impacts of heavy rains that affected much of the Corn Belt and other parts of the nation. There was a lot of interest, you could say, around the release of that June 28th publication. In the second column here, you're seeing a summary that was produced by the American Farm Bureau Federation, where they were computing the percent change of the 2019 June acreage total relative to 2018 data, and trying to reconcile that with their understanding of conditions in their respective states. NASS announced that it's going to make recontact efforts even with the publication of that acreage report. And you can see that in our August crop production report, what the revisions in that acreage look like as a percent change relative to 2018. So if you're looking at soybeans in particular, you can see that we got the sign right, but it was really hard at that point in time to say what the extent of the damage was going to be. Another fun fact about Mother Nature is that she's in control of a lot of things. And so these comments were provided by, again, Farm Bureau Federation agents, no one at USDA, but they raised really important and relevant questions for our estimation processes. So as I was looking through some of the anecdotes, we were talking about the prevented planting of corn, which has impacts on crop insurance and farm support programs. And so there's a decision that what was going to be dedicated to corn around that 1st of June reference got planted as soybeans instead. In Michigan, you can see that it changed the purpose for which the corn was planted and grown. And the significance of this at NASS, we treat these as distinct variables. So something took a running jump out of the corn for grain category and into the corn for silage. So we're going to feed it to cows instead of take it to market. You can see a number of comments related to the weather and growing conditions in these respective states. And they can be summarized as not good. Are they going to be as good as they were? And it's going to take a miracle to make it good. Just broadly, you can see that this summarizes economic decisions, concerns about progress and condition of the crop, relationships to trend yield, and important weather conditions around critical stages of the crop. So the decision support tool can help us address at least a few of these issues. It grew out of collaboration with University of Florida researchers in the agricultural engineering department. It started with the agroclimate tools, which were compiled by the Southeastern Climate Consortium, which is a group of 8 universities in the Southeast. Presently, it is managed by faculty and staff at the University of Florida. And the main idea with these tools was that they were decision support tools for farmers. When it comes to our collaboration with this team, we decided to customize those tools for internal use at NASS. And so, first of all, we're trying to meet the needs of our agency internally. Began with a pilot program in Nebraska in 2015, and we've made some nationwide expansion as of summer of 2017. You can see some of the data and services that we're consolidating here. There are 3 major public data inputs. These are all public data sources, and when we release the slides, the links will take you to some of those references. But we're inputting Oregon State's PRISM climate data, as well as the real-time mesoscale analysis data produced by NOAA, and then another USDA product by one of our sister agencies, Natural Resources Conservation Service, Soil Survey Database, or SURVO. I've listed here just a few of the many open source or free software underlying this. So we have database management in MySQL and PostgreSQL. This one in particular relates to a spatial database that we built. You have Apache Server PHP and WordPress for the content management. And as of this writing, it's in R version 3.4.3. You can see several of the packages that are loaded into this related to data manipulation, data ingestion, and visualization. To my knowledge, this agroclimate tool is not on the CRAN repository, but it's also an important piece of this. The idea is that this is going to be kind of a menu-driven structure, not unlike what our NCES college showed. Down here, a NAS team member is really operating through a menu-based browser, and that makes things intuitive, but it kind of belies some of the things that are happening in the background here. So we have both a spatial and systems database here. The R scripts are deriving and aggregating statistics, some of it in near real time or in batches executed at a couple times during the day. And the main idea is that we're just curating multiple data sources, and presently they're being matched to NAS deliverables. There is talk about making an API to get some more granular data out of what we're curating. But this decision support tool allows the user to visualize, summarize, and export the data for their purposes. As I mentioned, it's being vetted by field offices for use in their routine duties, in particular in relation to this crop progress and condition report. You can see some of the menu-driven parts of this, and in bold here, those are the parts that are supported nationwide at this time. You can have summary and advanced summary reports and weekly maps that I'll display. And because of the sequence of our publications here, this Monday morning, 9 Eastern Standard Time is an important time to have the previous week's weather available and summarized. This is a rough idea of the menu that a user would interact with. So you can see that they can export information for their respective states, districts, or counties. The time period here, the numbered weeks, again, would correspond to that crop, we call it the crop weather report, but you can also specify a date interval here. And it's drawing in, I've made annotations, data from several different sources, the PRISM data sources for precipitation and air temperature. This ARID is a water stress index combined from PRISM data and that soil database. The real-time mesoscale data is used to compute night temperatures, and then heat stress is, again, coming from the PRISM database. And there are actually some pretty substantial technical problems that had to be solved here. For example, if you're trying to compute nighttime temperature, you're talking about weather that's accumulated in the evening the previous day and in the early morning the current day, or managing changes across time zones. So hats off to the people who did that. For field office review, the crop progress and condition report, it's disseminated through our field offices on a weekly basis. And they're probably a little closer to the average data user in their respective states. You can find some variation in the information that we release through those reports, though. And so as I compared, for example, Wyoming and Illinois for the same reference date, no particular reason for this date, I saw that what was available in Illinois was state and district weather and weather maps. And the concerns aren't always the same in each state, but we do have crop growers in Wyoming. And so there might be opportunities through this tool to standardize or provide additional useful data if it is of interest to our field offices and their data users. So for example, I've just exported with a click of a button the Wyoming district level precipitation and temperature data. So again, that could be woven into that report. And then we have some really excellent mapping capabilities in this tool that I'll show off here. But in the April 29th report, you'd be summarizing the events of the week before. You're looking at week 17 of 2019, the week prior of the same year, the same week of the previous year, and then activity related to the past 5 years. And you can see how those things differ. I'll show some examples of the maps that we can export here. It's been developed for NAS along the lines of states or for our 12 regional field offices. So you can get maps simultaneously for the entire group of states under your region's purview here. And I'll just show the precipitation data as it related to those hurricane events. So this is Texas around the time of Hurricane Harvey. So as it made landfall in Rockport and then decided to hang out over Houston the next week. You may have a hard time reading the scale here, but you're looking at 40 inches or more in the most intense areas. And they may be back in that shape even recently. This augments some capabilities that we have with our spatial analysis section. For references, you can see the work that Claire Boyan and her group have done using synthetic aperture radar to quantify the amount of field that is inundated. It's also related to our crop forecasting program. So my colleague Hab Benesha has been active thinking about cotton yield forecasts. And in Texas, we have knowledge that says there are 2 pockets of cotton, one in the west, one more coastal. And you can guess that one of those was affected pretty profoundly. In this map, you're looking at the entire southern region around the time of Hurricane Irma. And so you can see how the range of rainfalls here, it made landfall, and then the storm passed through much of the region. And so some of this rainfall would be more significant or detrimental to the development of the crop than others. And our spatial analysis group also has a publicly available flood assessment for Hurricane Irma. This relates to our acreage issue that we've experienced this year. And you'll be able to see on the right kind of the 2019 progress as it relates to the 5-year average. And on the left, you'll see the precipitation. The range is controlled here, so you're going to have in the ballpark of 7 to 9 inches in some cases. So as we go, week 14, week 15, rains are coming. Week 16, 17 concentrated in the south. High, week 18. So we start to have a plateau in the planting here. And more rainfall throughout the state. No rest, more rainfall. And you can see how significant the difference is here, where we were 5 years ago versus the delays in planting that are there this year. And this kind of calls back some of the comments that the American Farm Bureau Federation had. Just a couple words on the potential for uses in modeling and planned extensions to this tool. You can see the Illinois district level precipitation and temperature growing degree days reported here by district. In this particular case, we're looking at the May 1st reference date to May 31st and comparing this to a 30-year normal. And so you're seeing highlighted in red here some extremes. There's a thought that this would push some sort of notification to field office staff that an event is happening in some locality in their state or in their region. I would also mention that the same thing that's turning these cells red are basically a 0-1 indicator variable. So that could be useful for modeling, for example. One of the Farm Bureau Federation's comments related to trend. And so in the pilot program, we thought about pulling in NAS official statistics and seeing how things shake out related to trend. So this positive trend is indicative of a lot of the development in corn over the years. There's been a lot of innovation, but you can see fluctuation around that trend. In 2012, there was a pretty profound drought throughout much of the Corn Belt, so that's why you're seeing there. One of the things that we're eager to see happen is an extension incorporating crop simulation modeling. And so this is used extensively in the agricultural engineering background, for example. with knowledge of where the crop is located and soil conditions, weather, and management of the crop, these kind of simulation-based models, not even necessarily incorporating survey, can produce information about the growth stages of the crop, which is one thing that we monitor, the crop progress. It might also be able to produce estimates of yield, so it could be useful in yield forecasting and in the season yield estimation. It incorporates information about the growth stages or crop phenology and the health of the crop at critical points in time. One last thing that I'll show here is that we're assembling a wealth of information linking to external monitoring tools. Some of these are created by USDA at NASS specifically. So for example, the Cropscape tool is hosted at George Mason, is kind of a web-based portal for interacting with our land cover classification product, the Cropland Data Layer. We have information from University of Nebraska's Drought Monitor, El Nino Southern Oscillation discussion, hurricane, and information from the High Plains Regional Center. Just in conclusion, the decision support system is providing a wealth of timely and relevant auxiliary data. We've tailored it for use inside of NASS first and offered it to our field offices for their routine duties. There are opportunities for standardizing some of the data products that we create and release to the public. And the weather data that we were curating complements a lot of our other approaches and available data. At NASS, we have survey data, administrative data, remote sensing of many different types. And part of the fun research challenges that we have to work on are finding meaningful ways to combine those all to enhance the official statistics we produce. There are more developments in the works, so thank you for your time.
Are there any questions for Nathan?
Hi, thank you for your presentation, Nathan. Quick question. So I see the tool takes in a lot of data. How would you account for which is maybe there are some predictions that are made or some uncertainties around the occurrence of events? Is there a formal way that you incorporate those in your models?
Research being done. No, I think this is definitely part of the
Exciting research that's going on at this agency. Our spatial analysis has some interesting groups, and what you get from their products might be a little different from what you get in the survey or in the administrative data as it's accumulated at other parts of USDA. And as I said, there's some really interesting research opportunities. Illinois is actually going to be a case study that we take on kind of at the behest of the Secretary of Agriculture to see if we can improve between that June and that August report, or offer some ways to kind of step down the changes instead of releasing at those two discrete points. Carol?
Is this available to farmers and the general public eventually?
I can't speak to that at this moment, but it is using public data inputs, and so even as we were kind of vetting the product with our statistics division, they were asking, can you export the maps? Is there anything proprietary? And so I think the answer is the contents at this time are public, and if they see fit to disseminate that information, they can do it. There's no public login for this particular tool, for example.
Probably here as well. So my question relates to basically the data providers. For example, you have the climate normals, and they get updated, let's say, the 10 years at one point. Then you have to update the data that you're using for the app. Oh, for example, you're using one climate weather station in order to predict one area, in order to compute the state estimates, but that water station shut down or there's a new one in town that you need to query and update the basically the stream of data that you're getting for your data provider. How's the process to do so?
A really good question, and one that I'm not sure I can fully speak to. I do know that in part of her work, Noemi's done a lot to validate or kind of compare data sources from multiple places. And I think a lot of what is happening in that spatial database, for example, it is, you know, some of these are graded products that we're averaging up. So it's not necessarily dependence on one particular station on one particular day. So there is a little bit of robustness built into that. As long as we can assume that those data products are going to operate in a similar way into the future, that's a good way to implement data.
Any other questions? So next, and our final speaker is Baiwan from the University of Virginia, and he'll be talking about the cost and impact of software.
Actually, let's see if we can get that there. What's the Control L? Nope. Nope. Oh wow. Can you all see it there? Let's try out. Yeah, it's gray out.
Okay.
Oh, good enough. Welcome. Thanks for standing here and those that are watching. My name is Baiwan. I'm from the University of Virginia. I'm delighted to share some of our work on measuring the cost and impact of open source software as intangible capital. So this is the research team. Basically, this is one part of a larger collaboration between NCSS, which is part of NSF, and as we saw earlier in this session, they have multiple objectives. One of them is to track innovation, research and development. One part of what they use in their toolkit is survey data. Here at UVA, we are helping them different projects on how to make those more robust and finding other ways to strengthen those that methodology. Usual disclosures for those that apply, for any opinions on this presentation. So currently, NCSS economic indicators do not capture the scope and impact of open source software outside the business sector. And they wanted to address this issue by getting some answers or some estimates on some of these questions. One of them were how much open source software is being used, who is creating it, when is it, how fast is it being created or deprecated, the costs and benefits associated to it. So first off, I want to make a distinction between what is an open source software and an open source project. This is a quote from Kino Fisher, CTO and co-founder of Joule Computing. An open source project is not a collection of lines of code that make up a repository, but it includes all contributions to the community. In the proprietary software, that would include documentation, marketing, service support, all those services around the code. It's the same thing with open source software. But at this stage, we're going to focus on direct contributions. That means who and what is being changed in the code base. So if someone were to ask you, what are all the applications that you can access for your iPhone? The normal thing that people would use is go first and look at the App Store. That's the most natural way to get that data. For open source software, it works kind of similar. So many languages will have some project package manager that's going to query that data. So let's start with a definition. What are we going to query? Well, the definition that we're going to be working with is any software that has an OSI approved license. OSI standing for the Open Source Initiative. So these licenses include MIT, IFC, ESD, etc., Apache. But we also want to distinguish between what would be a website template, student homework, Stack Overflow, question and answer, and a package that's meant to be shareable, discoverable, reused, and has added some functionality to the environment. So in order to address that, we want to make sure that they're production ready. It's not something that's being developed and it's not meant to be used. And we want to have something that's usable right now. So not something that was designed for version 1 of R. So we wanted to make sure that there is some release that works with a current version of the ecosystem. So we're going to first look at different registries. For example, CRAN and PyPy, and for the Comprehensive Archive Network and the Python package. And this registry basically has all the data the package manager needs in order to query, solve that dependency, find the code, install it in your computer, make sure that you can use it. So we're going to look at registries, but the registry also have where the code is hosted at. That would be, for example, some remote. And the biggest one, and the one that we're going to be using, is GitHub, which is the world's largest remote hosting platform. And once we get to GitHub, then we're going to use their API to get some information. And we're going to look at the repository. We're going to get commit data, who is doing what, where, when. That will give us, for example, one user contributed to that project, added that many lines at that point in time. And we can also get information about who those people are. We can get their names, emails, where they're located, what companies they're working for, where they're located at, etc. So one of the questions was how much is out there, trying to get a census or a count. We can start here. This is as of a couple months back. We can look at CRAN, how many packages are registered, same for PyPy. We can parse out which ones have an OSI approved license and they met some criteria of quality. For example, if the package is using CRAN, it will have CRAN checks, where it has a test matrix and it passed. That means that the package passed whatever test they developed. Same, for example, with Travis CI for continuous integration. We're going to look at the subset that are in GitHub, and then we're going to use the ones that we can get the data for in order to do further analysis. So one question is this a one-man, one-woman project, or is it an open source project accepting pull requests from other people? So about half of the time, those projects are 1 or 2 person led. Very few have more than 50 contributors. That's one of the insights that we got early on the study. We wanted to identify who these people are. Basically, for example, whether they're coming from businesses, academia, is it under like part of their job or hobby, etc. But this is user-provided metadata. So many times people do not fill out the whole profile. For the field of company, we see that only 3 out of 10 actually put a company listed in their public profile. Out of those, we only are able to parse a subset of that. The estimates do make sense. It's mostly business led, and you have seen this especially in recent years. But we're working on expanding, finding new ways to identify a larger set. One aspect of measuring the scope of open source software is that we want to get some estimates of how much is being used as the part in research and development. So how much effort, money is being invested The approach that we are adapting is based on an effort. So how much is one person's time and effort, or effort person hour? And that's using the lines of additions and deletions from the repository. And that takes a framework from Kokomo 2, which is one of the standard measures to estimate costs in proprietary software. Then we pair that with wage data from BLS, and we adapt the methodology used the Bureau of Economic Analysis and ACD to make an approximation of what would be that estimate. For the subset that I mentioned before, we estimate that for PyPy and CRAN, that subset, it's in the order of 2.4 billion 2017 USD. So that's significant. How much is being of that whole share is outside the business? That's something that we're refining in order to add that. We can also look at measures of use and reuse. For example, how many downloads a package or some language or some tool is having. There are many issues with using download codes, but it's a good estimate. We can get that from whatever the server is giving those stars or downloads. For CRAN, we see that the most downloaded package is RCCP, which is used in a lot of packages. And we can also look at reuse, which is applications or projects that are depending on some other code. And we see that ggplot2 is one of the most widely reused package. So it's a measure of reuse that would be the equivalent of a citation in Boolean metrics. So if you all can see that plot, that's the CRAN dependency network. So I'll go over it quickly. It's a directed graph. So we have nodes, which are the circles. And if I can zoom in, okay. So that has an arrow. So basically from one node to the other, establish a relationship where one package is dependent on the other when like the arrowhead. And the more packages depend on one package, the larger is the node. So we see that ggplot2 is bigger than the others. That's because other packages are depending on ggplot2. And we can also see different communities, and those are the colors. For example, ggplot2 is a visualization package. That would be the bluish community. But we can also see, for example, web-based community. Those are packages that implement curl, HTTP protocols, JSON, and XML data formats. There is also a distributions-based community over here. This one is a progression. And we can see other communities as well. So this allows us to understand what they're being used for and how they're interacting in between. So why are we doing this exercise? Well, there are some policy implications. One of them being right now for software, in the national accounts, we tend to categorize those into three types. Free package, those would be your licenses sold to, your own accounts, and your custom software. That excludes the whole phenomenon of open source software. One of the reasons why that's probably the case is lack of data in order to adapt the methodology. So this is one way that we're contributing to expanding what data sources are available to implement or to make more comprehensive estimates. And this is overall one example of how we're repurposing administrative data, which GitHub has as part of their business model, in order to use for statistical research. So what are the next steps? We are now expanding rather than just doing our PyPy and a couple other registries to capturing the universe in GitHub. So that's about 5.2 million repositories that have an OSI approved license as a machine detectable attribute. As I was checking a couple minutes ago, we have 2.9 repositories already parsed. That should be done by Wednesday. And then we're going to collect the data for the others. So what are we going to do? What are we going to use the data for? Well, we want to estimate the distribution of contribution by sectors. That's ongoing work currently. And we also want to analyze the network structure between projects, project contributors, and contributors themselves. Any questions? Hopefully you'll learn something and enjoy the presentation.
Any questions?
So my question is about the business contribution side of things. So, like ggplot2, the person who originally wrote that is like the chief technology officer of our studio. And so I'm wondering if you can talk about maybe the business influence. I know I'm pretty active in like the R Twitter community, and there's a lot of people in that community who are pretty upset by the fact that our studio is like really pushing out the tidyverse like really hard, but it's because they pay the money and they have the resources. I'm just wondering if you could talk about that a little bit.
Good question. So I'll address a few things about the issue. First, so let's start with the national accounts. What is being captured currently? If a company, let's say Microsoft, is paying software engineers or programmers, or a university is paying a professor to develop some package, some software, that's being captured if it is under the national accounts framework of you have database people, you have computer scientists, then that would be captured. Whatever it is doing outside that is not being captured for national accounts. As part of the influence or business collaboration open source software, its origins were basically a predatory way of companies to compete among themselves. So you would open source some product in order to have basically delegate your competitor in something that you were not good at. That changed a lot and has changed a lot. Now many companies are using open source software because it makes sense for them. And it includes all benefits in the literature of how if you pay your employees to develop open source software, they learn more, they know what needs to be fixed, they can use a lot of software. And there are other businesses as well. The issue is open source software is not free. It's built on the effort and sanity of all this put in the time. So if it doesn't have documentation, you probably cannot use a package that you know how it works. So businesses that are using it have an incentive to contribute it, whether it's led only by corporate sponsors, let's say. That's one part of it. It has its pros and cons because not everyone can allocate enough time to do so. I like tiny birds.
Two quick questions. You said analysis by sector. You mean by industry? Second question. If they change the software a little bit, it is a new rev 0.0.0.1 before, you're downloading it, and just have to download in your system.
So I'll start with the second one. Downloads are a noisy measure. For example, if you were to take downloads from the GitHub registry, which is a beta feature, that one captures everything quite well. And you could have one package manager, let's say for the Julia language, which should be our Julia users from here. They start instead of downloading the whole repo. That would not be trackable at all. Or CRAN, which is the one figure that we estimated. Those are from the CRAN network. So basically, any CRAN server has one count as being downloaded. If you have a package that you're using for continuous integration, you're a Travis, every time that boots up that container, it's going to download that. So you might have a good share of the downloads just being part of the development process and not actually unique users. That's an issue for a lot of developers There are new tools in order to address that. So in order to get who is using my product, so I can keep track of whether what I'm doing is worthwhile. That's one aspect. And this first question that you had was, can you say? Yes. So for the national accounts, they do a breakdown, basically by academia, government, foreign. So when I say, let's say business, I don't mean, for example, like industries as in tech, or is it energy, or defense, intelligence. I mean, who is investing there, and the framework for national accounts, because that's like one of the applications, right, to track it. But you could have it more segregated into who are the 10 top contributors, or is it, for example, mostly people as hobbies or part of their job? So we can do more analysis as we collect more data.
Any other questions?
You didn't address this, but this is the question I had when I came here. So what's the cost benefits an organization using something that's open source versus paying the software?
So the first one is it's free as in beer. So for many organizations, it can be quite costly, especially, for example, like licenses. What is the true cost? Well, in some regards, you might have options, whether it's like support if you have a commercial license. Many products sometimes are dual license. So you can have it basically open source, but with a limitation on commercial applications or a copyleft. If you have a copyleft, then you cannot bundle it in your commercial application. So you might want to use some other terms of the license in order to bundle it for whatever services you want. And there's also the whole business of or open source, which is I'm going to open source my main application, but I'm going to sell my education training. I'm going to sell you whether you want to set up in a secure environment, say a national research center, or some sensitive information, then I'm going to help you set up that infrastructure. So how you use the open source. I would say currently it depends on the organization, but the logical or the trend would be towards using open source in many applications, if not most of the domains.
Are there any questions for Arwan or any of the other speakers? No? So that wraps up the session, and thank you so much for a very informative session and to the audience for participating. And also to our organizers, Peter Mayer and Mike Down, for a great event. If I could just request everyone to move to room 1 and 2. Mike Down will have some remarks. Thank you. Thank you again, everyone.